These are your worked out solutions to your geometry review sheet. Be sure that you're using a grading pen and you show any work that you didn't already have. On number 1, we are going to convert a scale drawing into real life dimensions. So we're going to start by using our scale, which tells us that 60 inches in real life is equal to 1 inch on the scale. So that's going to be the first fraction in our proportion. The second fraction, we're going to convert each of our two measurements. So for the width, that's our smaller measurement, we're going to line up 1.5 inches with 1 inch, and we can put any variable in the remaining spot. From there, we can use either scale factor or cross products. That's going to give us a width of 90 inches. And then we can do the same exact thing for our second proportion. Start with your scale factor, and this time we're going to be finding the length. And so we can put our variable lined up with the real life distance and 2 3/4 inches lined up with the scale distance. That's going to give us a length of 165 inches. So for our dimensions, width is 90 inches, length is 165 inches. Next, we're going to convert those measurements into feet. You can do this however you would like. If you're not quite sure how to set it up, you can always go back to using a proportion and lining up your variable with the feet. So if we set it up that way, each of our proportions would use the measurements. So 90 inches for one of them, 165 inches for the other. When you solve your proportion, you're going to end up dividing by 12 for each measurement. So our new dimensions would have a width of 7.5 feet and a length of 13.75 feet. And finally, we're going to use those dimensions to calculate the area. Area of a rectangle would just be length times width. So we're going to multiply 13.75 by 7.5. And that'll give us an area of 103.125 square feet. So this time we're going to put feet squared instead of just regular feet. Okay, next we're going to use a protractor and a ruler to draw a triangle with some specific measurements. First, I'm going to start with my side length of 4 inches. So using your straight edge, draw a side length of 4 inches. And we want to make sure that we label each part of this so it's really easy to tell. So this is 4 inches. And from there, we're going to draw in our angles. So I'm going to pick one of the two endpoints and line up the protractor so that you can see the endpoint through the hole on the protractor. And I'm going to do 30 degrees on this side. So we'll put a mark where 30 degrees would be. It's also going to line up with 150. But since I'm using the acute piece, it's going to be 30 degrees. Okay, then we're going to draw in a line segment, again using your straight edge. And we need to make sure that we label this angle as 30 degrees right inside the vertex. Okay, next we're going to do a 50-degree angle. We're going to line up our protractor on the opposite side. And this time find 50 degrees. Make a mark. Use your straight edge to draw in your triangle just like that. And then we're going to label that this one is 50 degrees. Finally, it's a good idea to check to make sure everything is working together like it should. We know that every triangle should add up to 180 degrees. I currently have 80 of those degrees, so the final angle should be 100 degrees. And we'll use the protractor to check. So we'll line up the whole of the protractor right on the vertex of our third angle. And then we're going to move it so everything lines up perfectly. And once it's lined up exactly, we can check out this angle and see that it comes out to exactly 100 degrees like we would expect. Okay, next we're going to look at circles. We've got a wishing well that is 8 feet in diameter, and we need to find the area. Be sure to use your 4-step process anytime you're using a formula. So we're going to start with area equals pi times radius squared. And we can plug in 3.14 for pi. And if it's 8 feet in diameter, then that means the radius has to be 4 feet. So I'll multiply by 4 squared. When we multiply those numbers together, we're going to get a total area of 50 and 24 hundredths square feet. Okay, next we're going to explain the reasoning behind the formula for area of a circle. We saw a video that split this apart. You guys also did this in class where you cut apart the pieces to try to make it look like a parallelogram. If you remember, we can look at these pieces right here. There's 4 arcs of your circle. So if I trace 4 arcs of the circle right here, that's going to be half the distance all the way around your circle. So the length of the parallelogram is going to be half of the circumference. So if you remember, circumference is 2 times pi times radius. So if we want to do half of that, circumference divided by 2 is actually going to be equal to pi times radius. So it might be a good idea to show the original formula and how that transforms into pi times radius. It also asks for an explanation. So we need to say something about how the length of the parallelogram is half the circumference of the circle. Okay, so again, you'd want to say something about half the circumference of the circle is the length of the rectangle, and show your formula to show exactly where pi times radius comes from. Okay, next we're going to do the ice cream problem. You have a sphere of ice cream that gets pressed into a cone. If the ice cream melts, you want to find out if the cone will overflow and show some sort of a proof as a reason why. We're going to start with, let's do volume of the sphere. So that's going to be 4/3 pi times radius cubed. It tells us radius of the sphere, it's 4 centimeters. So when I plug everything in, we're going to have 4/3 pi times 4 cubed. For this problem, I'm going to leave it in terms of pi until I absolutely need to do something else. That'll help me compare because I really just want to know which one's bigger. Okay, when I start multiplying those out, I'm going to get 256/3 pi, or when I divide, I'm going to get 85.3 repeating pi, and that's going to be in cubic centimeters. Okay, so that's for the sphere in blue. Next, we're going to do the cone. We'll do that one in green. So volume of a cone is area of the base, which is pi r squared, times height, all divided by 3. So we're going to do pi times radius squared. The diameter of the cone is 8 centimeters, so that means the radius is also 4 centimeters, just like our sphere was. So 4 squared times our height of 9, all divided by 3. When I simplify that expression, it's going to come out to be 48 pi cubic centimeters. So again, if you want to continue multiplying out by pi to get an exact number, that's fine. But right now I have enough to tell me that 85.3 is larger than 48. Therefore, there's more ice cream than will fit in the cone. So if you let it all melt, then it will overflow. So for my explanation, I said if the ice cream melts, then the cone will overflow because 85.3 pi is greater than 48 pi. All right, number 5, we're going to be using Pythagorean theorem to determine which of the side lengths could have a hypotenuse of 40 inches. So remember Pythagorean theorem, we're going to do a squared plus b squared, so each of the leg measurements needs to equal the hypotenuse squared. So this one's just going to be kind of a guess and check. We can start by figuring out the hypotenuse squared. So 40 squared would equal 1600. So we're trying to figure out which of those 4 options, when you square them and add them together, will equal 1600. So we'll just go through each one. 18 squared plus 24 squared is 900. That one won't work. The second one, 14 squared plus 48 squared is 2500. That one will not work. For part C, 24 squared plus 32 squared is exactly 1600. So that one does work. And then just to confirm, part D, 16 squared plus 30 squared equals 1156. So that one will not work. So correct answer will be part C. Okay, number 6, this is looking at cross sections. We want a cross section of a rectangular pyramid. So right away we know the middle one won't work. And we want it cut parallel to the base. This first one right here is cut at a 90-degree angle. This one is perpendicular. And perpendicular just means that it makes a 90-degree angle. So that one will not work. When we look at this one is cut parallel to its base, so that's the one that we need. So we'll circle that one. It says then name the shape of the cross section. So right here, we're looking at that shape. It looks kind of like a parallelogram, a little bit tilted, but remember it's a side view, so really this would just be a rectangle. Be careful, we don't know for sure that the base is a square, so we'd want to be a little bit more general unless we had that information. Okay, next we have some kids making mud pies with 5 pails of mud. So we're just trying to find the volume of all of these pieces together. So we're looking for volume of a cylinder, which is going to be area of the base, pi r squared, multiplied by height of the cylinder. The measurements that we have, radius is 6 inches and the height is 8 inches. So we'll plug in what we know. Pi, we'll use 3.14 times 6 squared times 8. And when we multiply all of those together, that's going to be 904 and 32 hundredths. This is going to be cubic inches because we're looking at volume. It did ask for 5 pails of mud, so I'm going to take that answer and multiply by 5 to get my final amount of mud. Once we do that, we're going to get a final answer of 4,521.6 cubic inches. Okay, next we have a sunflower that is staked to the ground with 2 wires. So if we try to sketch out this picture, each wire is 2 feet above the ground. So this distance would be 2 feet. And you can picture that it goes out 1.5 feet on each side. That shows our 2 wires. And then we have 4 flowers total, so we'll need to take that into account at the end. We have some right triangles, so we're going to use Pythagorean theorem again. We're looking for the hypotenuse. So we'll start with our formula, a squared plus b squared equals c squared, and plug in what we know. So 1.5 feet squared plus 2 feet squared is going to equal the hypotenuse squared. When we square each of these, we're going to get 2.25 and 4. And together that's going to be 6.25 equals c squared. The opposite of squaring something is square rooting it, so we'll do the square root on each side to get a length of 2.5 feet for the hypotenuse. So again, that just gave us this side. There's 2 wires for each flower, so we can do 2.5 times 2. That means each flower uses 5 feet, and there were 4 flowers total, so 4 times 5 feet is going to be a total of 20 feet. And that should give us enough wire to make sure we can hold up all of those flowers. Okay, next one, we have the radius of a yellow marble at 1 centimeter, radius of a silent ball at 4 centimeters. Figure out how many times bigger the volume of the pink one is compared to the yellow one. So these are both spheres, so we're going to use our 4/3 pi r cubed formulas. This one is for the 1 centimeter marble. So 4/3 pi times 1 cubed is going to be 4/3 pi. Kind of like before, I'm just comparing these two numbers, so I don't necessarily need to multiply it all out just yet. Then for the silent ball, we're going to have 4/3 pi r cubed and plug in our radius of 4 centimeters. So times 4 cubed. When I simplify those ones out, I'm going to simplify it partially so that I can keep the 4/3 pi and multiply by 64. So now I'm comparing to figure out how many times larger this one is compared to this one. So that means I can take the smaller amount and multiply it by some variable. So we'll use x. And that'll have to be set equal to the larger one. So I'm just trying to figure out what number I multiply the smaller one by to get to the larger number. So that's what my equation represents. From here, I'm going to divide both sides by 4/3 pi. And when I divide 4/3 pi by 4/3 pi, that is going to cancel, and that is going to cancel. So now I have x equals 64, which tells me that the silent ball is 64 times larger than the marble. Okay, so I wrote in my final answer, and we're ready to move on to the next one. Okay, this one, you saw one very similar to this on your quiz. Be sure that you remember what complementary and supplementary mean. That was the biggest mistake I saw. Supplementary is going to be 2 angles that add up to 180 degrees. So we're going to set up our equation. Angle A, 2x plus 40, plus angle B, x plus 20, together has to equal 180. We can combine like terms. So 2x plus x is 3x, and 40 plus 20 is 60. So now we have 3x plus 60 equals 180. Subtract 60 from each side. So we get 3x equals 120. Divide by 3 to get x equals 40. Then for part B, find the measure of each angle. So angle A was 2x plus 40. So we're going to plug in 40 in place of x. It's going to be 80 plus 40, or 120 degrees. And angle B was just x plus 20. So that would be 40 plus 20, or altogether 60 degrees. Final piece, just to make sure answer is reasonable. These two numbers together should add up to 180 because we knew that they were supplementary. And when we check, 120 plus 60 does in fact add up to 180 degrees. Okay, next, rectangular prism has a surface area of 148 square inches. The length is 5 inches and the width is 4 inches. What is the height of the prism? So we're going to start with our surface area of a prism formula, which would be 2 times length times width plus 2 times width times height plus 2 times height times length. And we're going to plug in a 5 anytime we have an L, and we're going to plug in a 4 anytime we see the width. Also, 148 is the surface area. So we can start 148 equals 2 times 5 times 4 plus 2 times 4 times height plus 2 times height times 5. And then we can combine or simplify each individual term. So this piece would be 40 plus 8h plus 10h. All needs to equal 148. Then add 8h plus 10h to get 18h. Bring down the rest of what you've got. And now it's just a two-step equation. So subtract 40 from each side. So you get 108 equals 18h. Divide by 18, and you're going to get a height of 6 inches. And then kind of look back and just make sure that's reasonable. We had lengths of 5 inches and 4 inches, so 6 inches seems reasonable for that one. Okay, next, this time we're looking at a rectangular prism and its volume. So we can start with volume is area of the base times height of the prism. The width is 8 and the height is 12. Volume is 960. So we can substitute 960 equals area of the base would be length times width. So I'll do length times 8 times height of the prism, which is 12. Then when we continue simplifying, we're going to get length times 96 equals 960. Divide by 96 on each side, and you get a length of 10, and then this would be in centimeters. We're just talking about a linear measurement, so just plain old centimeters for that one. Okay, next, number 13. A circle has an area of 254 and 3,400 square meters. What's the radius of the circle? So it's asking about area. We have area. It's asking about radius. So we'll start with our area formula for a circle and substitute in 254.34 for A. We could use 3.14 for pi, and we're looking for the radius, so we'll just leave that as r. In order to get the r squared by itself, we're going to divide both sides by pi. So divide by 3.14. That's going to come out to 81 equals radius squared. Just like when we're doing Pythagorean theorem, we're going to do square root of each side to get 1r, and the square root of 81 is 9. So this is in meters. So final answer, 9 meters is equal to the radius. All right, next we are looking at a circle and its circumference and trying to find the radius again. So I'm going to use my circumference formula that is 2 times pi times radius. Again, it's asking about the radius, so that's why I'm choosing that one instead of pi times diameter. We're going to substitute in everything we know. So 2 times 3.14 times radius. And we can combine these two to be 6.28 and divide by 2 pi on each side. This one doesn't come out quite as nicely as some of the others. If you do 4 or so digits, you're going to get 9.0159. So could round that to 6. You could round to the nearest hundredth place, so that would come out to 9.02 for the radius. And then last part, we're going to put units on it, which is miles. Okay, finally, you are responsible for all of these formulas that are on your review sheet. So we'll just go through each one. Area of a triangle is base times height divided by 2. Circumference of a circle is either 2 pi r or pi times diameter. Surface area for any prism is going to be 2 times the area of the base plus the perimeter of the base times the height of the entire prism. Volume of a cylinder is area of the base times height, so that would be pi times radius squared times height. And volume of a pyramid would be area of the base times height of the pyramid, all divided by 3. Area of a circle is pi times radius squared. Surface area of a rectangular prism is 2 times length times width plus 2 times width times height plus 2 times height times length. Volume of any prism is area of the base times height of the prism. Volume of a cone would be area of the base times height divided by 3. Since it's a circle, you'd have pi r squared times height all divided by 3. And finally, volume of a sphere is 4/3 pi r cubed. Again, make sure that you're comfortable with each of those formulas so that you can use them on the test. All right, that concludes all of your review solutions. Be sure to study and good luck on the test.